Welcome to a lesson with Dr. Powell. Let's take a look at how we might verify a trigonometric identity. Suppose we have something like this: cosine squared theta minus 2 is equal to cosine 2 theta over sine squared theta. And we say, is this true? Maybe we have a question. Maybe we don't know it's true. So we shouldn't say it's true if we don't know it's true. So we'll just draw a line. We have no way. And we can't assume that we have equality here. So what we can do is we can just think of both parts as an expression, and we can rewrite the expression. Now, if you rewrite an expression, that's not called solving. Solving means you isolate something in an equation. This is not solving. This is simply simplifying or rewriting. So in this form, let's use identities, which we can, in order to rewrite things. We'd like to rewrite these things in such a way that maybe eventually it'll be very clear that they're equal. But we keep this distinct when we're trying to verify an equation. We cannot assume the conclusion when we are that we are trying to show, for that would be circular reasoning. Okay, so what we can do, we can replace things and think about it. In the end, we want something like this. You see this cosine 2 theta? We think in our minds there's something we can replace here that would get us something over here. Notice we have a sine squared down here. And we have a cosine 2 theta up here. It'd be nice, you notice how we have a subtraction here. It'd be nice to split this up in the numerator into a subtraction, in a way that maybe things would cancel and work into this right here. Let's just see. Let's try to rewrite cosine 2 theta maybe, using one of our identities. Maybe just for starters, let's just think cosine of theta plus theta, which ends up giving us cosine squared theta minus sine squared theta. So we could think of that for starters just like that. In fact, that looks pretty good for now. Okay. And then notice that we can divide, right? Sine squared is in the denominator. So this is just like taking this numerator and multiplying it by 1 over sine squared. But that multiplication distributes across. So it can distribute to there and there. It's the same thing as just saying take this and the division splits across the subtraction. You could think of it both ways. Okay, and in that light, or it's like unadding a fraction. If you have a fraction here and it had the same denominator, you can unadd it, just split it in 2 parts like that. So we would end up having cosine squared theta over sine squared theta minus sine squared theta over sine squared theta, which is 1. This right here is cotangent squared theta minus 1. Do we have an identity for cotangent? We want to relate cotangent squared to cosecant squared. You should remember there's a Pythagorean identity. If we don't remember what they are, that's fine. If we just remember this one, cosine squared plus sine squared theta is equal to 1. And we divide everything by something, so we get a cosecant and a cotangent. Well, that would be dividing by sine squared, because cosecant is the reciprocal of sine. So divide everything by sine squared, you'd end up getting a 1, cosecant squared, and you'd end up getting cotangent squared. So if you solved for cotangent squared right here, you would end up having cosecant squared minus 1. So this right here, so this is just a note off to the side. Okay. So then this would become cosecant squared theta minus 1 minus 1. And notice that that is, yes, that's equal to that. And so therefore, we have verified the identity that we started with, and it is true. Notice that we just worked on one side to make that one side look like the other side. It is possible to change both sides, but we're not going to interact between the 2 sides as we go. We're going to stay on the right, on the wall, on the side of the wall that it needs to be. Thanks for watching.